Hi, grade 9s. Today we are going to do a lesson on similar objects. So we're going to try and start by doing this investigation. So the substitute is going to give you two different types of graph paper or grid paper. The first type will be the standard graph paper that you are used to using. The standard graph paper that we are used to using is the 0.5 centimeter stuff. That's the stuff that we're all used to using. But the substitute teacher will also give you 2 centimeter graph paper. Okay? And she or he is also going to give you a ruler. So let's get the party started here. With the smaller grid paper, draw a rectangle. Keep the dimensions under 10 grid squares. What does that mean? Well, it means that if this is your grid paper and you're going to draw your rectangle, that the length and the width both have to be under 10. Basically, you have to, and when you're doing it on the smaller paper, you want to keep it under 10 so that it's drawable on the larger grid paper where the squares are bigger. Now, whether you're using the smaller grid paper or the larger grid paper, here's what you're going to do. But you're going to start with the smaller grid paper. You're going to draw a rectangle. So here's my rectangle. I'm going to go there's one side, there's another side, there's another side, and there's another side. If we're labeling it in terms of lengths, obviously this is 2 squares, this is 7 squares, this is 2 squares, and this is 7 squares. Okay? You don't have to draw one that is that exact same size. As long as this number and this number, which is in effect all 4 numbers, are less than 10, you're good to go. So draw yourself a rectangle on the smaller grid paper with a ruler. Once you're done doing that, you should label the sides of the rectangle with letters at each corner. So going back to what I had here, how I would do that is I label this as A, B, C, and D. It doesn't matter how you label the corners, as long as you go sequentially. As you can see, I've gone in this direction right here, A, B, C, D. You can go in any other direction, that's fine. As long as you go and do that, it makes some sense, okay? Label each side of the rectangle with its length. We already did that, but we'll go back and we'll do it that way too. So that first 2 here, this is what AB is because it's the length between vertex A and vertex B. This 7 is what BC is equal to. This 2 is what DC is equal to. And this 7 is what AD is equal to. Something to keep in mind here is when we call this AD, I could also call this DA. It really doesn't matter. It just depends on whether you're going in this direction or in this direction. Either way is perfectly fine. You can call it AD or DA. It doesn't make a difference. It honestly doesn't. Now, using the larger grid paper, so the big 2 centimeter grid paper, draw the exact same rectangle in terms of dimensions. So whether it's a 3 by 7 rectangle like I have pictured here, or whether it's a 2 by 7 rectangle pictured here, whatever dimensions you used to draw the first rectangle on the smaller grid paper, use it to draw the exact same dimensioned rectangle on the larger grid paper. Label the corners as A, B, C, D as you did in the first one. And now this would be an appropriate time to pause this video because it's going to take some time to get that rectangle drawn. Once you have both those rectangles drawn, then what you need to do is measure the lengths of the sides of both rectangles and fill in the table below. So all of these answers are going to be different. They're going to be different because it's going to depend on what dimensions you chose. But here's what you're supposed to do. The large rectangle should come from the 2 centimeter grid paper. Using your ruler, measure the length of the side AB and write it out here in centimeters. Do the same thing for BC, do the same thing for CD, and do the same thing for DA. All on the 2 centimeter grid paper. Then do the exact same thing on the 0.5 centimeter grid paper. Understanding that this takes some time, this would be another spot where you might want to pause the video. Then, in each of these cases, take the length of the large rectangle and divide it by the length of the small rectangle. In each case, you should get 4. So in other words, the ratio of the large dimension to the small dimension should be 4:1 in each of these cases. And it doesn't matter what size your rectangle is. As long as you measure it properly and you did everything else appropriately, you're going to get 4:1 for every side. So what do we notice? Well, we notice that the ratio is 4:1 for all sides. Okay? Okay. And our topic today are similar objects. Objects are said to be similar if you take all the sides of one object and you multiply them by the exact same number and you get the lengths of the other object. They should look like the same shape, only one of them is bigger than the other. Okay. Moving on. And here we go, we just see it reworded. An object is similar to another object if it's larger or smaller. If it's larger, we call it an enlargement. If it's smaller, we call it a reduction. Angles are the same, so therefore they have the same shape, but the size of two similar objects is different. So we see here that star 2 is a reduction of star 1. They're similar, except the second star is just smaller. So this example here asks us which triangles below are similar. So here's how we name triangles. This is something that'll come in handy once you're past grade 9. This is triangle A, B, C. This is triangle D, E, F. This is triangle G, H, I. Just let me take care of something here. My dogs are being very loud. So, door is going to get closed. There we go. All right. So, We name triangles by saying triangle ABC, triangle DEF, and triangle GHI. We always name the triangle by naming each of the 3 vertices in the triangle. And again, it doesn't matter the order, but typically we use alphabetical order. And if we're using letters, A, B, C, D, E, F, and G, H, I follows alphabetical order. Now, by looking at these 3 triangles, we are asking which triangles look the same. So, if we look at triangle ABC, let's actually do it a little bit differently here. Let's take the magic pen and focus on ABC only. There we go. What we see when we take a look at triangle ABC is we see a triangle where the 2 sides going up are the exact same in length, and they come together and meet in the middle. If we shift the focus to triangle DEF, we see a triangle where the sides don't meet in the middle, and the 2 sides going up are not the same. So, because of that, this triangle would not be similar to ABC. Going to triangle GHI, the sides go up and meet in the middle, and they're the same. So just in general shape-wise, it would match up with ABC. So triangle ABC should be similar to triangle GHI. Now, how will we show it? Because it's nice to say that things are similar, but we need a mathematical way of proving it. So what we need to do is we need to find which sides match up to one another and see if the scale factor for all the corresponding sides is the same. So first of all, let's take a look at this side right here. Which of the sides in triangle GHI does that match up with? Now, in this particular question, there might be 2 possible answers. In most questions, there would only be 1 possible answer. More than likely, the answer that would make sense here would be side GH. So we need to find the scale factor between these 2 sides. How do we do that? It usually makes the most sense to take the bigger number and divide it by the smaller number. So if I take 15 and divide it by 10, I get 1.5. That tells me that side GH is exactly 1.5 times bigger than side AB. Now, if we take a look at all the other corresponding pairs, we need to see the exact same scale factor. So, let's take a look at BC. Which side does it match up with best? Well, that would be the other bottom or base of the triangle, and that would be side HI. So again, if we take a look at the ratio between those sides, we take 6 and divide it by 4, we get 1.5, the exact same answer. It looks like we are almost on the brink of showing that these 2 triangles are similar, but we must do the last pair to see if it holds. Now again, we have side AC, which would be 10, and side GI, which is 15. Now, it's simply academic because this is a calculation that we just did. No matter, we'll do it again. 15 divided by 10 is still 1.5. So because these are all the same, we would say that triangle ABC is similar to triangle GHI. And we've shown it mathematically because all the scale factors are the same. Next example. The next example is a diagram of a polygon. Specifically, it's a pentagon. It's not a regular pentagon because the sides do not have the same lengths. So it says to draw an enlargement. It doesn't specify what kind of enlargement. It just says an enlargement. So if we enlarge it, we could double the side lengths, and that would be fine. Now, so we could also multiply them by 1.5. It really doesn't matter. Now again, my ruler is not going to be accurate. So I'd like you to go ahead and just remember that my picture here is not going to look perfect. However, we'll still use it as a basis here. We'll use the idea that let's not do doubling. Let's not do doubling because that might be tough to figure out. Let's go ahead and, sheet of paper is 8.5 inches. No, yeah, 8.5. So that'd be over. Yeah, we're fine. We're fine to double. So let's double. So if we double it, then the base of this pentagon is 10 centimeters. So taking our ruler, I'm going to draw a base of 10 centimeters. There I go. Okay. Now, you make sure your base is drawn of 10 centimeters. You have to make sure that, and I know that's 10 because I took this and multiplied it by 2 to get 10. So I'm going to take 3 and multiply it by 2 and get 6. Likewise over here. You have to make sure that the angle here is 90 degrees or a right angle. So in order to do that, the substitute teacher is going to give you a protractor. Now, if you need to pause the video, go ahead. Once you have that protractor, this ruler is an awesome ruler because it's got a protractor built into itself. I can line it up and get ready to draw my 6 centimeter side. There it is. And I can cheat, so I'm going to. I'm going to clone this side, and I'm going to bring this guy over here and put him right here, just like his friend. Now, perfect. Now, ideally, I don't have these things at the bottom, but I can fix those up. And now we're cooking. Okay. Now, the only difficult part of this question is coming up with that peak. That peak, it might be tough for us to draw. How can we make sure to draw it appropriately? Well, we have here that this angle here needs to be 140 degrees. 140 degrees. Interesting. But this appears to be in the middle. So if it's in the middle, what we could do is we could find the middle of the 2 points here. Well, let's not screw around like that. Let's just use 140 degrees. So if I've got 140 degrees, then what would be important for us to understand is if that's 140 degrees, then this right here is 40 degrees. So in other words, we deviate from going straight up and down by 40 degrees to the right. So, gonna take my ruler, gonna deviate 40 degrees, so you're gonna have to get a protractor. Make sure you find out what 40 degrees is, and we're gonna go in this direction. And what I see here is it's 4 centimeters. Now again, I understand I see something here. I got to move this down, otherwise I'm not going to have enough room. Hopefully you do. Now I'm going to bring my ruler back because I need this to be 8 centimeters. So 8 centimeters is going to look something like that. And then I'll connect the dot over here, because once I have the other peak drawn, then I just have to do that. There's my new pentagon. Now, that's A, B, C, D, E. I should label this one A, B, C, D, E. But this isn't A, B, C, D, and E. It's A prime, B prime, C prime, D prime, and E prime. Okay? And the lengths are 10 centimeters, 6 centimeters, 6 centimeters, 8 centimeters, and 8 centimeters. That's how we draw an enlargement. So just recapping what we did, we chose a scale factor. The scale factor that I chose was 2. Could you have picked 1.5? Absolutely. Could you pick 3? Sure. Could you pick 2.25? Absolutely. You could pick anything you want. It's nice to pick whole numbers, but you do have to pick something bigger than 1. If you chose 0.5, for example, you would be making this polygon smaller, and therefore you wouldn't be drawing an enlargement. Okay, now moving on, I think, to the last example. We have 2 objects here, and they are similar. We are being told that, so we can assume that we don't have to show it. But we are asked something. We are asked to find out what xy is. What is xy? Xy is this side right here. Then we are asked to find DE, which is right here. We have to use the given information to help us. The given information will be able to tell us what the scale factor is. So I need to find 2 corresponding sides where we know both of the sides. For example, I know that AB will correspond to VW. Unfortunately, I don't know either of those sides. I also know that BC corresponds with WX. Again, I don't know those sides. So I have to pick corresponding pairs where I know both of the sides. So, of course, the 2 sides with corresponding pairs that I do know are AE and VZ. So I'll divide the bigger one by the smaller one to find the scale factor. So scale factor is going to be 12 divided by 8 is exactly 1.5. That's our scale factor. So what does that mean? That means that everything, let me get my magic pen out here. Everything in this object, every side is exactly 1.5 times bigger than what we see in that object. Okay, so that'll help us figure out the unknown size. So part A asks us for x, y. So how will we do that? First off, we look at xy. Xy is in the smaller object. So because it's in the smaller object, we look at the corresponding side. It's 9 centimeters. And we know that 9 centimeters will be exactly 1.5 times bigger than xy. So to figure out what xy is, we are going to do something with 9 and something with 1.5. Now basically it's either going to be multiplying or dividing. So let's try and use some common sense here. If we know that 9 is bigger because it comes from the bigger object, would we multiply these or would we divide them? If you multiply by 1.5, you're going to get 13.5. Well, xy is not bigger than 9. So we're obviously not going to multiply. So we should divide. So we're going to take 9 and we're going to divide it by 1.5. In fact, whenever we do any calculation, let's just be clear here though. We found the scale factor from the big object to the small object, okay? If you do that when you do this, your scale factor will always be larger than 1. And when you're looking for something in the smaller object, always divide. When you look for something in a larger object, you are going to multiply. So 9 divided by 1.5 is 6. 6 what? 6 centimeters. Make sure to include your units. Part B asks us for DE. Now DE is that right-hand piece, and we see it corresponds with 4. So we're going to take 4 and multiply it by 1.5, and we'll also get 6. So both of our unknowns are surprisingly the same, 6 centimeters. Okay? All right. Your homework for this is on pages 341 to 342, questions 4 to 17.